So I'm very pleased to be here today, and I would like to thank you, Lawrence, and thank you, Fred, for the invitation. I met Richard Leakey only once, and I wish I'd met him many more times. I remember him especially in Toulouse when he was welcomed by my university with a MIF to receive the medal of the city. So today, the two main characters of my presentation will be chrome dry and Paranthropus robustus. On that image, you can see some friends working at chrome dry and being very, very happy to meet Paranthropus robustus, and also other specimens, organisms that we find at the site since 2014, when we decided to renew the excavations at chrome dry. And in fact, we realized that doing so, after 27 months of excavation since April 2014, that this site has much more to tell us on the evolutionary story of Paranthropus robustus, but maybe also on the evolutionary story of early Homo and other creatures. So at chrome dry, of course, we don't find only fossil hominins. We find many other creatures, big mammals like big carnivores, small animals like birds, micromammals, and tools. But I won't show you tools today because I hope Sonia and Inacio will come to South Africa to see them. So today I will present you some results of the field work that we have been conducting at chrome dry over the past 9 years. And also I would like to drive safely, Bernard, but I will also discuss one of my best activity as a scientist, which is comparative anatomy, and especially developmental biology. So at chrome dry, we find lots of fossil hominins and other creatures in situ, like this beautiful specimen, which we found in June 2016. I wanted a coffee this morning, and instead of a coffee, I got this one, which is quite a beautiful specimen because it's the most complete upper face of a Paranthropus robustus baby. It's an infant, and its upper permanent molar was not erupted. It was still in its crypt, and the root was little formed, so it was very likely less than 2 years old. And beside the teeth, this specimen can tell us a lot about the paleobiology of Paranthropus robustus and the way these creatures were growing. So beside the teeth, we can extract a lot of information from these kind of fossils, by investigating the way their skeleton grows, and specifically their face and the rest of their skull may have grown as compared to the skull of other creatures from other species, other infants, like for instance the tongue child or the Dikika baby from Ethiopia. Of course, we find not only craniofacial elements or maxillofacial elements, we find postcranials, hominin postcranials, but since they are not associated with cranial elements, we don't know if the fossil hominins from Unit P belong to Paranthropus robustus or belong to early Homo. Here, for instance, you see a beautiful calcaneus that has been found at chrome dry, which could be Paranthropus robustus or could be early Homo. And there aren't so many calcanei in the fossil record from that period. We also find other bones that are not very common. For instance, this patella, with some carnivore marking, has very interesting features and also some carnivore marking. And this patella comes from Unit P, also at chrome dry. It might belong to early Homo, or it might belong to Paranthropus robustus. We are also training students, and through the use of some European grants, we are training South African students in Europe. So I've been in charge of several programs. They've been called ESOP, to promote South African heritage in Europe and to train students in Europe and to try to facilitate their employability in South Africa when they return back to their country. And it's not that easy because we also want to prevent as much as possible brain drain. And in fact, it wasn't possible to spend all the money we've got from the EU because many positions were not filled. So I was very much interested by the discussion we had the past days. It was more than 4 million euro grants, and we had to return a lot of money to the EU because of lack of candidates who wanted to stay longer in Europe to be trained. So that's an interesting also aspect to consider when you want to develop this kind of projects. So Paranthropus robustus was born at Kromdraai. It was born at Kromdraai in 1938. And it was discovered by this gentleman, Robert Broom, who noticed that this beautiful skull, which has half of its left upper part and half of its right lower part, which is quite an interesting observation to make if we, and which could, in fact, indicate that there might be more of that specimen still in the ground at Kromdraai. We don't know where this specimen comes from at the site of Kromdraai because of that time. Robert Broom didn't use the same methodology as we now use at the site. But definitely we are investigating this just now at the site, trying to see if possibly we could find more of that specimen. So Kromdraai is located not so far from Johannesburg in a small valley to the south of an area which has been called the cradle of humankind. And in this area, you can find names of sites in yellow and in blue. So in the sites in yellow, you will find Paranthropus robustus and sometimes early Homo. And in the other sites, with the names in blue, you will find Australopithecus only, with only one exception, which is Sterkfontein, where you find very little of Paranthropus robustus. In fact, only isolated teeth, 5 of them, which are not sufficiently diagnostic to tell you much about the paleobiology of Paranthropus robustus at that time at Sterkfontein. And all these sites are represented by unconnected karstic sedimentary infillings. And none of them contain both taxa with sufficiently diagnostic remains. This might change in the future with what we are doing at Kromdraai now. So in April 2014, when we restarted excavating at Kromdraai, we spotted an area which was previously thought to be completely sterile. And in fact, after a few days of excavation, digging deeper than 1.5 meters, we started finding beautiful fossils, including fossil hominins. So at that time, we asked Bob Brain to come, and he kindly visited us at the site, and we took this beautiful picture of him. Bob used to work at Kromdraai 20 years after the discovery of Paranthropus robustus. He spent 3 field seasons at the site between 1955 and 1957. And he found beautiful fossils there. So here is a phylogeny of Kromdraai. And you can see the site with a photo taken in 2000. And you can recognize on this photograph taken some years later the same features to the southeast, to the south here. And you can see what the site looked like after nearly 1 year of excavation. So we could expose a new area here where we started to dig and find some soft sediments which were indeed very rich in fossils. This is another phylogeny of the site with a picture that I took at the site very recently, less than 2 months ago during fieldwork. And this is the site after 27 months of excavation since April 2014. So I will very briefly present you some results, focusing again on comparative anatomy and on 2 aspects of comparative anatomy. So this video has been taken in 2017, and you can see all the features of the Chrome B historical site over there. So this is a quite narrow trench here, which is approximately 40 meters long and 2 to 3 meters in width. And this is Chrome B. And all this area to the north of this narrow trench, narrow fissure, represents the new area where we are digging now. And there are more areas where we could work in the future, very close to this one, which might be also very rich in fossils. So Chrome is much, much bigger than it was previously realized. But again, there are some very interesting areas in Chrome B, the historical site, and especially here, which could in the future be quite interesting to investigate, to try to find more of the type specimen that Robert Boom discovered and described in 1938. So why working at Chrome and why being so interested by Paranthropus robustus? So in fact, I work at Chrome and it's the fault of Fred and Bernard, because they published beautiful studies on Paranthropus, and they always raise this question, which is really central when we want to deal with Paranthropus robustus. Paranthropus robustus belongs to a family of fossil hominin species. We call them robust australopithecines. And the question, one of the most important question is this group polyphyletic or monophyletic? If it's polyphyletic, there is a possibility that Paranthropus robustus evolved from an older and perhaps more primitive creature from the south, which is called Australopithecus africanus. If it's not, it's very likely in that case that Paranthropus robustus arose from another creature, another organism from East Africa. And the good candidate could be Paranthropus aethiopicus. There are other possible candidates. So my interest is to try to contribute to this debate from the study of new features that we could extract from the skull and in the adults and in the juveniles, and also from the study of developmental biology, trying to find juveniles, Paranthropus robustus, to see if the developmental processes in Paranthropus robustus were compatible with those that we could observe in Australopithecus africanus. And there are several other questions to be addressed. I already mentioned the question on the monophily of robust Australopithecines, but another interesting question is Paranthropus in general, so are robust Australopithecines is it the sister taxon of early Homo? Do they share, in fact, a relatively recent common ancestor? And also, if this group is monophyletic, why do we observe, as already demonstrated by these authors, why do we observe in Paranthropus robustus features that are apparently less derived than Paranthropus boisei? And if Paranthropus aethiopicus is the common ancestor of these two organisms, why do we observe less derived features in the cranium of this skull and other anatomical other specimens of this species, and particularly in the face, which is more prognatic, and in the cranial base, which is less flexed. So my suggestion is that we could try to extract more information from ancient specimens, from new discoveries, so more data mining, beyond the study of robusticity, beyond the study of these enhanced masticatory features that we find and that have been described in Paranthropus robustus. And also my suggestion is that we could also explore a little bit more the evolutionary developmental paleoanthropology. I mean, the developmental features that we could find on new specimens of this species. But these two ideas can be applied to other species, of course, other early hominin species. And they could be very helpful to try to expand our knowledge on the paleobiology of these fossil species, explore a little bit further also the phylogenetic relationships between Paranthropus robustus, other robust Australopithecines, and other early hominin species, and also perhaps give us more information about the life history, strategies, and the ecology of these species. So I will start with one very simple example, which is cochlear shape. So I've been very interested by cochlear shape for several reasons, and this is the main reason here. The cochlea, in fact, which is the auditory part of the inner ear, the cochlea in animals and in humans can emit some stimuli, some sounds, after being stimulated, but I can also spontaneously emit these sounds. And these sounds are very useful to determine if there is some hearing loss in one individual. And these sounds are very interesting because they contribute to a mechanism that adjusts the hearing sensitivity at particular frequencies. So it's the mechanism that helps you to hear someone in a noisy environment. And this is very interesting because these sounds are not the same in modern humans, in males and females. So years ago, we decided to explore the possibility of finding a morphological proxy showing this sexual difference in the cochlear shape among modern humans using clinical data, medical data. So to make it short, this is the result of a PCA analysis, and you will find all the females from France and South Africa here, and the males are here. And these are the two maps, the mean maps of females and males among modern humans, showing with a color code the torsion along the path of the cochlear shape. And when you divide the mean shape of males and the mean shape of females, you notice that from the base to the apex, this area, which corresponds to the treatment of higher frequencies, is the most distinct between males and females among modern humans. So we decided to explore this in fossil hominins, not yet for sexual dimorphism, because we need to build new models using chimpanzees, bonobos, and gorillas, and we need a larger samples of non-sex specimens. But we try to explore the possible usefulness of cochlear shape as a proxy as a possible taxonomical proxy. So to make it very, very short, I have only 1 minute. Oh, okay. So you can see here that Paranthropus is very, very distinct from Australopithecus, and this potentially indicates that Paranthropus was more into the lower frequency range as compared to other early hominids. So what about patterns of development? So patterns of development are very interesting to explore because, in fact, the skull is composed of different building blocks which may interact differently depending on the species. And recently, we found new specimens at Cronbry which allow us to map cranial development across various ages during infancy. I mean before 3 years of age. So we could compare Paranthropus robustus and Australopithecus africanus using these features we find in the skull, in the face, in the base, and in the cranial vault. To, again, address this question, is this group, is Paranthropus monophyletic or polyphyletic, and do we find close relationships, close affinities between Paranthropus robustus and Australopithecus africanus using these developmental features? So one very interesting feature is the suture that is located between the premaxilla and the maxilla. I have 1 minute or 2 minutes? 2, okay, thank you. So this suture between the premaxilla and the maxilla is interesting to investigate because the only species of primates, fossil or extinct, which lost its premaxilla during development because the premaxilla is locked to the maxilla during the very early skeletal development is Homo. I mean, in modern humans, in Homo erectus, in Neanderthals, you will not find a premaxilla in very young specimens. It's gone. And now, if we explore this feature in this very young Paranthropus robustus specimen found at Cranbrook, you will find no premaxilla. The premaxilla is gone also. Here, you just have a slice through the premaxilla of that specimen, and you notice remnants of the premaxillary suture behind the gubernacular canal here for the permanent canine. And even though there is a trace of an incisive suture on the surface, you can see here that the suture is completely closed. So it's not functional anymore. So in Paranthropus robustus, we find the same pattern as modern humans. If we investigate now the morphology of the nasal floor and its relationship with the alveolar process here, we also find that they are not at the same layer, whereas in adult Paranthropus robustus, they are in the same layer. And also we find that the thickness of the palate is not thick in these young specimens. So this challenges this pattern, which has been described a long time ago, which says that in fact in Paranthropus robustus, everything evolves at the same time because the face is a unit. In fact, from this evidence, we find that the face is not a unit. There are building blocks within the face in Paranthropus during its development, and they are independent. So they should be treated as such when we do a phylogenetic analysis. And the last interesting result we got is this one. In fact, we try to use the plane which corresponds to the lateral canal to orientate the skull horizontally. And when you do so, you find that tongue is oriented that way. This is the plane of the lateral semicircular canal, and you can see that this area, which corresponds to the cerebral fossa, is very high relative to this plane. Whereas in Paranthropus robustus, this area that corresponds also to this cerebral fossa, which is here in this recently discovered specimen from Cranbrook, is further down. And this is very interesting because it has been shown years ago by Jeffrey that this orientation might correspond to a differential growth of the cerebral and cerebellar components of the brain. So just the very last slide to show you that using this new evidence from Cranbrook, we can also show that this very interesting specimen, who you know, SK54, is not, in fact, Paranthropus robustus, but very likely early Homo, because it differs from the specimen we've got at Cranbrook. And last slide. So the next step now is to investigate the ontogeny of early Homo from specimens discovered at Cranbrook and in other sites in South Africa, and also to interpret the fossil hominins we've got from deeper layers at Chrome Dry. Thank you very much.